right, so these are the three pieces that were given for our triangle. Asked to solve the triangle, we got to find the other three pieces. Since we're given three sides, basically we got to find three angles. So drawing it out like we've done before. Matching up sides to opposite angles, we've got little a, which is 5, we've got little b, which is 8, and we've got little c, which is 12. Now everything is illustrated. Back in the last section when we solved these types of problems, we spent some time discussing the kinds of cases that evolved as you set up each particular problem. Here, all the sides are given. So when you think about cases, we would have a side, side, side type of case. And we really haven't seen that yet. I'm stressing the importance of recognizing that at this point because we have law of sines we can play with, and we could try setting up this problem to solve with law of sines, but we're going to notice right away there's a problem. Like say, for instance, we go in alphabetical order. In terms of solving for the angles, I start with angle A up here. If I'm going to figure out what angle A is using the law of sines, I would take the sine of A and place that over its opposite side measure of 5. Right? That's how we set up all those types of problems. But what I want to set that equal to, I want to set that equal to a ratio where I know both the angle and its opposite side measure. And there's no such case like that, right? And the best we could do to compare this to something else, well, we'd have another variable in play, and we don't want that. So that's why law of sines is not going to work. This is not a right triangle, so using the traditional trig ratios isn't going to work either. Instead, what we do is we use a thing called the law of cosines. And the law of cosines states, if I have a side squared, and I set that equal to one of the other sides squared plus the third side squared, and then subtract twice the product of those other two sides, and then I multiply on the cosine of the angle opposite that side I started with. Essentially, that's my little formula I can use for the law of cosines. Now, where that comes from, we could spend some time deriving. To be honest with you, it's a little complicated, so we're not going to do that. All right? We're just going to take what it is, we're going to use it. And if this is a formula I can use, brought to me by the law of cosines, plugging in what I know, trying to figure out angle A first. Well, plugging in what I know all the side measures, right? I know little a is 5, so I take 5 squared, I set that equal to b squared, so that'd be 8 squared, plus c squared, that'd be 12 squared, minus 2 times b, 8, times c, 12, times the cosine of angle A. So once we plug in all of our given information, we should have just one variable left to solve for, which we do. And in this case, it's that angle A. You'll notice that this angle A, not only is it included in the cosine function, but I've got a whole lot of stuff here that's attached to it through multiplication. And I need to keep that grouped. So as I start to try to isolate the cosine of A, it's very easy to have some issues with your order of operations, so be careful. As I try to isolate this, what I'm going to do is I'm going to subtract these squared values over, because after all, they're only added on anyway. I'd have 5 squared minus 8 squared minus 12 squared if I bring that over. Now, if you want to calculate as you go, you can. You could go ahead and get this difference right here of all these squares. But that's going to be equal to negative 2 times 8 times 12 times the cosine of A. And if you want to go ahead and calculate all this out, as well as all of this, not a bad idea. Just understand whatever I get over here, since that's attached to the cosine of A, I'm going to divide that over. So I divide this product of negative 2 times 8 times 12, whatever that is, over to the other side. And that means the cosine of A is going to equal this calculation. Now, if you calculate as you go, you've got a couple of numbers you're just dividing out, right, to get whatever that decimal is. If you haven't calculated it out as you go, you got to be real careful how you're entering this in. You know, you have this grouping up here divided by this grouping down here. See, the common mistake I usually see is people go through and they'll calculate all this out as their first step, and that's fine. But then when they go to divide, they try to divide all of this at once, and they start messing up the grouping symbols. So if you're going to divide all of this at once down here, make sure you use parentheses. Make sure you're just multiplying between these values inside the parentheses, okay? That decimal, by the way, when you calculate it out, if you're checking with me right now, it should be, where do I have it? I want to say it's 0.953, if I'm reading my notes here correctly. So you can check and confirm that with me. Either way, we get that decimal back. We're trying to figure out what A is. And we saw something very familiar like this with Law of Sines. How am I going to get rid of that cosine? Okay, you're going to use the inverse cosine, right? So you slap on the inverse cosine of all this. That takes care of the cosine part of the function. It drops out, and angle A ends up being, again, check this. I got 17.6 degrees. So if A is 17.6 degrees, we can place that on our triangle over here to help us keep track a little bit better. And if we continue with the theme of alphabetical order, we can move on to angle B. What's nice is once you do have an angle in place, even though I had to use the law of cosines to get started on this problem in solving, once I have an angle in place, I can go back to the law of sines. Because if I want to figure out what B is, and I know B is opposite side 8, I could take the sine of B, put that over 8, set that equal to sine of angle A, which we just found to be the 17.6 degrees, over its opposite side measure, which was 5. Right, now it makes sense to use law of sines again. Using law of sines, cross multiply. We've got 5 times the sine of B equal to 8 times the sine of 17.6, at which point we understand we're dividing that 5 over. We're doing this calculation here. And then because we're trying to figure out what B is, make sure you're keeping track of which function you're working with. Now we're working with sine. In trying to get rid of this sine function, you'll take the inverse sine of the decimal that you created right here. When we do that, angle B should come out to be 28.9 degrees. And you've got your two angles, right? That means we've got our third. We take the 28.9, we take the 17.6, we add it together. We subtract from 180, we get 133.5 degrees for angle C. So sometimes it is necessary, depending upon the case that's presented, like side, side, side here for the given triangle, sometimes it's necessary to start the solving process with the law of cosines. But once you go through the initial process to get at least one measure back from that law of cosines, then you can use law of sines to finish. This time we'll be given that angle A equals 46.5 degrees. Side B equals 10.5. Side C equals 18. we illustrate the given information, we set up triangle ABC, angle A, 46.5, side B, 10.5, side C, 18. So there's our illustration. If you make sense of the case that's presented here, the case that's presented here, we've got a side, we've got an angle, we've got a side. So side, angle, side. As we've gone through and solved problems, especially in that Law of Sines section, we have not encountered a side, angle, side problem yet, because you can't use Law of Sines. In fact, where we use Law of Sines usually is going to be on a problem that has two angles given. If you've got angle, side, angle, if you've got side, angle, angle, then you can use Law of Sines. If I'm trying to solve this problem, obviously I'm looking for, well, basically a side measure down here, and then two angle measures, right? All right, if I start with the side measure over here, this would be little a, right? Using my law of cosines, I would have to set up a squared equal to b squared plus c squared minus 2bc cosine of angle A. And if I plug in what is known here, a squared will equal little b squared of 10.5 squared plus little c squared of 18 squared minus 2 times 10.5 times 18 times the cosine of angle A, which is 46.5 degrees. We find using the law of cosines to solve for a side is a little simpler, because really all you have to do here is calculate all this out. Okay, you could punch all that into your calculator at the same time. Once you get that value, that will equal a squared, and if that equals a squared, then you're just going to take the square root of that answer, right? So we do this entire calculation, we take the square root of that answer, we find that little a here should equal, I've got 13.2 if you want to check that.
Why did we square that?
Since it equals a squared.
Oh.
So side is 13.2. Just like we saw before, you use the law of cosines to get yourself started to find either side or angle measurement. Once you find that side or angle measurement, then you can use the law of sines. So using the law of sines, if I stick with the alphabetical order theme, angle B would be next. I'm trying to figure out what angle B is. I take the sine of B, I place that over its opposite side measure of 10.5. I set that equal to, have to be the sine of 46.5 degrees over opposite side measure I found to be 13.2. Do our cross multiplication. Divide my 13.2 over. Sine of B equals this decimal value right here. And since we're working with sine, trying to find an angle, we'll apply the inverse to that decimal we get. When we apply the inverse to that decimal, we should find that angle B is 35.2 degrees. Place that on the triangle. Got our two angles. Since we have our two angles, finding the remaining angle of C, not so difficult, right? 35.2 plus 46.5, that sum subtracted from 180 is 98.3.